For over a century, modern agriculture has depended on synthetic fertilizers. Nitrogen, phosphorus, and potassium, mined, refined, and shipped across the globe, became the invisible backbone of industrial food production. But buried deep in agricultural research papers, Cold War archives, and forgotten field trials is a shocking truth. There was once a soil bacterium so effective it nearly eliminated the need for fertilizer altogether. And then, almost overnight, it vanished. So what was this bacteria? Did it really work? And if it was so powerful, why can't farmers buy it today? The discovery that shook agriculture. In the early to mid-20th century, scientists studying soil ecology noticed something strange. Certain crops, especially legumes, grains, and grasses, were thriving in poor soils without added fertilizer. The secret wasn't the plant, it was the microbes living around their roots. One group of bacteria stood out: nitrogen-fixing soil bacteria. These organisms had the rare ability to pull nitrogen directly from the air, where it makes up 78% of the atmosphere, and convert it into forms plants could use. Among the most promising were Rhizobium, which are symbiotic bacteria in legumes, Azotobacter, which are free-living nitrogen fixers, and Azospirillum, root-associated bacteria for grains. Field trials in the 1930s to 1960s showed jaw-dropping results. Crop yields increased 20 to 60%, synthetic nitrogen use dropped dramatically, soil health improved year after year. In some test plots, fertilizer use was reduced to zero. The bacteria that nearly replaced fertilizer. The real breakthrough came when scientists realized these microbes did more than fix nitrogen. They also stimulated root growth, increased water efficiency, released plant growth hormones, improved phosphorus uptake, and even restored damaged soils. In the Soviet Union, Eastern Europe, India, and parts of South America, microbial inoculants became a serious alternative to chemical fertilizer. Some regions even rolled them out at a national scale. For a moment, it looked like agriculture was about to change forever. Then, it disappeared. By the late 1970s and 1980s, these biological solutions quietly faded from mainstream farming. Not because they deteriorated, because they didn't fit the system. Here's why. First, they can't be patented easily. Living bacteria reproduce naturally. You can't lock them into proprietary formulas the way you can with synthetic chemicals. That made them unattractive to major agribusiness corporations. So, here's the thing. These microbes are actually pretty fragile. They're sensitive to heat, UV light, storage time, and even chemical-treated seeds. Without refrigeration and, really careful handling, a lot of these products lost their effectiveness before they ever reached farmers. Now, here's another layer. They actually threatened $1 trillion industry. Synthetic fertilizers are one of the most profitable sectors in agriculture. A self-replicating solution that could reduce fertilizer demand was, well, let's just say, inconvenient. As a result, funding dried up, research stalled, products vanished from shelves, and when we look at modern biofertilizers, why you still can't buy the miracle version? Well, they do exist, but honestly, they're just a shadow of what was once tested. Why is that? Regulations treat microbes like chemicals, not like living systems. Many strains weren't preserved properly. Large-scale trials were abandoned halfway through. Plus, modern farming practices like pesticides, monoculture, and tillage kill beneficial microbes on contact. So, in short, the bacteria didn't fail. Modern agriculture just moved on without them. But here's the ironic twist. Today, fertilizer prices are skyrocketing, soils are degrading, yields are plateauing, and scientists are quietly returning to the same microbes that were discovered nearly a century ago. There's new research into regenerative agriculture, soil microbiomes, carbon farming, and microbial seed coatings. All of this suggests that the lost solution may actually be making a comeback, this time with modern science to back it up. But here's the question no one really likes to ask. If soil bacteria can feed crops, heal soil, cut costs, and reduce pollution, why are farmers still locked into chemical dependence? The answer isn't scientific, it's economic, and that's why this bacteria, once hailed as the future of farming, was allowed to disappear.